Teaching for problem solving starts with the learning the abstract concepts and then moving to solving problems as a way to apply the learning skill. Explain, practice, apply. The major shortcoming of this approach is that students learn very early in their school that the stories they encounter are going to be solved using the skill they just learned. Therefore, there is no point in reading the story to see what is happening and what needs to solve. The numbers can be lifted out and the skill applied. Think about problem solving. Students need guidance on how to problem solve. This includes the process of problem solving and learning strategies that can help them solve problems. Four-step problem solving process. You need to understand the problem. You first need to figure out what the problem is about and identify the question. Devise a plan, carry out that plan, and look back and reflect to see if you got the right answer or something went awry. In problem solving strategies is visualize the problem, look for patterns, predict and check for reasonableness, formulate conjectures, and justify your claims at the end. Create a list, maybe a table or a chart, simplify or change the problem, and write an equation. Mathematical problem solving is founded in curiosity. The ways of thinking described here becomes the tools by which students can enter into unfamiliar and novel tasks. Teaching through problem solving. This approach means the students learn mathematical through inquiry. They explore real context problems and situations and models and from those explanations they learn mathematics. They might be described as an upside down from teaching for problem solving. The problem or task presented at the beginning of the lesson and related knowledge of skills emerge exploring the problem and then the answer. What fraction of the flag is blue? So students look. They may decide to write each fraction apart of the flag. After students have solved the task, the teacher might bring the class back and highlight important ideas and mathematical thoughts. Then the teacher could say, hey, share your ideas and we can ask questions to help build and connect conceptual and procedural knowledge of this question. Through problem solving, we need to focus students' attention on the idea. When solving problems, students are necessarily reflecting on the concept, develop mathematical practices and processes students to be the doers as they are doing the math, develop students' confidence in identities. They begin to identify themselves as the doers in the math. Build on students' strengths. Students can apply strategies that they understand and that lead to their learning. Allows for extensions and elaborations, extend and what-if questions, and they engage students so that there are fewer discipline problems. Provide formative assessment data. Students discuss ideas, draw pictures, manipulatives, define the solution, exit tickets. Invite creativity. Students enjoy the creative process of problem solving. Search for patterns. Show how they figured out something. A worthwhile task might be an open-ended or definition. It may involve solving problems. It includes words and symbols. It may only take a few minutes to solve, may take weeks to investigate, may be a real life or abstract. Tasks can be problematic initially, but then they become a routine as the students' knowledge and experience grow or be problematic for some students, but not for other students, based on their perceived experiences. There is no prescribed rule or method to solve. There is not a prescription that there is one correct solution. Tasks that promote problem solving are cognitive demanding, meaning that they involve higher level thinking. Low cognitive demand tasks, also called routine problems or lower level tasks, involve stating facts. High-level cognitive demand tasks, on the other hand, involve understanding, analyzing information, and applying it in evaluating strategies, as indicated by other levels of Bloom's taxonomy. Have multiple entry points, meaning that the task can be approached in a variety of ways and has varying degrees of challenge within it. Having multiple entry points can accommodate the diversity of learning in your classroom. Grades K through 1, 6 bowls of cereal are placed at 2 different tables. Draw a picture to show a way that 6 bowls might be placed at 2 tables. You can find more than one way. How many ways do you think there are? Does this allow for multiple ways in explanation of the matter? Yes. Does it use visual representation as a means for students to reason and think of other ways? Yes. Open up opportunities to make connections between concepts and procedures? Yes. Picture book, 2 of everything. A couple finds a pot that doubles everything they put into it. How many students would be in class if our whole class fell into the magic pot? Or Harry Potter and the Sorcerer's Stone. How big Hagrid would be if he were twice as tall and 5 times as wide as they are. Table that shows each student's height and weight and look at the pattern, which is 3 to 1. Then they can figure out Hagrid's height and width and see whether he can keep the same ratio. Can create a scatter plot of width and height and see where Hagrid's data would be plotted on the graph. Practice refers to a variety of tasks or experiences focused on a particular concept or procedure. Drill refers to repetitive exercises designed to replicate the procedure or algorithm. Students have an increased opportunity to develop conceptual ideas, alternative and flexible strategies for solving and making connections between concepts and procedures. Drill improves procedural knowledge but not conceptual understanding. When the number of problems is reduced and time is then spent discussing problems, both procedural and conceptual knowledge are supported. So a small amount of problems worked many different ways. Involve 3 of the 8 teaching practices: wait time, pattern talk, revoicing, saying more, who can repeat, why, when, what do you think, tell me more. Teachers need to anticipate before the lesson starts what might happen, how can it go, monitor and observe strategies students are using, selecting from observation, selecting strategies for public discussion, sequencing strategically, sequence the presentation to emphasize mathematical ideas, connecting designs the questions that connect strategies and mathematical concepts. When considering questioning, we need to level the questions. We have to have lowering questions, but we also have higher level questioning. Make sure we have more of the higher level questioning. The type of targeted understanding. Make sure the questions must address procedural and conceptual knowledge. The patterns of the question, initiated response. Do not lead to class discussion. Who is thinking of the answer? Make sure all students are talking. We can talk to a partner, for example, or we can discuss throughout the whole class. You respond to an answer, your students' answers to find out if other students think the conclusions made are correct, whether they are justified and why, and if there are other strategies or solutions to the problem. What to tell and what not to tell. Mathematical conventions such as symbols, terminology, and labels need to be addressed. They should be introduced after concepts have been developed as a means of expressing or labeling ideas. Alternative methods are an important strategy that does not emerge naturally from students, should be introduced as an other way, but not the only way. And then clarification and formalization of students' methods. Help students interpret their ideas and point out related ideas. Example, 38 plus 5 equals a student to add 2 to 38 to equal 40, and 3 more is 43. Utilize the make 10 strategy. Writing is a reflective process and involves students in metacognition, which is connected to learning. Metacognition refers to consciously monitoring and regulating of our own thoughts. It helps facilitate classroom discussion. A written record or a pre-drawn picture can be helpful to reference during discussions. Graphic organizers can be useful to help students connect representations to a particular problem and help solve that problem. They can write their ideas as they're going through the I think framework. They need to individually think about the task. They can think about the problem. They can write down and think of how to solve it, identify a strategy to solve or multiple strategies, notice how their strategy helped them solve the problem, and keep thinking about the problem. Does it make sense to them as they